Hi everyone, and welcome to this new webinar about VerticaPy. Today we will see some of the ways by which VerticaPy reduces the total cost of ownership. My name is Badr, and I will be followed by Umar. During this presentation we will tackle many interesting subjects. In order to understand how we can reduce the TCO, we need to see the different data science challenges and how they can really slow down any project. We will then introduce Vertica as a solution to these challenges. We will explain how Vertica can provide machine learning at scale. After that, we can understand the importance of VerticaPy, which is an abstraction of Vertica SQL. It provides many tools, including the DB-Link integration, which allows users to query any database and to do federated queries. We can then see a quick demo of a product and conclude with a Q&A section. To increase business value using machine learning, we need to go through many steps. Generally, a business starts off as static with simple reporting and drill down. With a lot of work, it is possible to use basic rules to monitor and alert. At that stage, we are still reactive and we need a little pusher to gain a big business value. Machine learning can help any business to become proactive by discovering new patterns and predicting future outcomes. With a lot of time and a lot of work, any business can automate these alerts and become dynamic. But most of the value resides on the path from reactive to proactive, as it just needs the right technology and just a bit of work. However, we can easily face many challenges when dealing with data science use cases. If we are using legacy systems, we always need to add costs of the hardware. Additionally, when trying to process the data, most of the old technologies require loading the data in memory to be processed. And as we are storing more and more data, they become hard to process. A solution is downsampling, but that means we are possibly losing information. Even stratified downsampling is not enough for most of the use cases. And then, when we try to combine many technologies, it slows down the development. Even after creating a model and solving the use case, it still needs a lot of time to deploy. It makes any data science use case hard to put into production. For example, the traditional data science journey is full of roadblocks. The data scientist needs to connect to the database and collect the data. He will probably extract a sample, but does he have the rights to do it? Does he correctly follow the GDPR? Then he needs to process the data in memory using probably Python, R, or Spark. That's not all. He still needs to find a way to put it into production. Even if he succeeds, what if he needs to update the model? The downsampling can destroy the accuracy of the model. The maintenance needs extra cost. Maybe some consultants will have to do it, and there can be many security breaches. We need to figure out a solution to all these problems. And that's Vertica. Vertica is an MPP columnar database developed by Mike Stonebreaker. It was developed to be performant and to be able to query terabytes of data. As it is a relational database, it uses SQL. It has many advanced analytical built-in functions to be able to do machine learning at scale. And it has a powerful query engine which allows Vertica to be able to query anywhere. Vertica can scale out linearly for faster performance. Its columnar storage allows it to only parse the needed data and to compress it accordingly. Besides, it has its own kind of storage. It uses projections to be able to query quickly the needed data. That's not all. Vertica has in-database machine learning. It provides many powerful algorithms. It is possible to do regression, classifications, decomposition, clustering, anomaly detection, and even time series forecasting. Vertica supports the entire data science lifecycle, from data exploration to model training and management. You can create models, evaluate them, manage them, and more. It is even possible to bring outside models like PMML or TensorFlow frozen graphs. Vertica is a complete end-to-end platform. Vertica is different from its competitor. It is one of the few databases having its own ML implementation. It does not rely on third-party technologies. Everything is coded from scratch in C++. If we take the example of the random forest, Vertica can train the different trees in the different nodes. Even more, each split of the tree can be computed by the different nodes. The data just need to be correctly segmented. Some of the Vertica algorithms are even faster than other well-known technologies like Spark. Our random forest implementation is an example. It is obvious that doing the prediction in database provides many advantages such as security, time, etc. However, most of the time data scientists prefer to train their model in their own data science environment. The example in this slide demonstrates the performance edge of in-database training of Vertica over Spark. Besides, Vertica extends all the possibility with user-defined extensions. They are functions customized by you in one of the 4 available programming languages: C++, Python, Java, or R. So why not just build your own data science playground? When we have such a powerful SDK and so many data science functionalities in our product, a natural idea is to develop a Python layer at the top of it. Vertica is a relational database with high security, in-database machine learning, and many integrations. On the other hand, Python offers one of the best data science experience with Jupyter notebooks, amazing rendering capabilities, and so many interesting extensions. VerticaPy is a layer at the top of Vertica, allowing users to have a Pythonic experience while wielding all the power of Vertica at the same time. It is open source and you can directly contribute on GitHub. VerticaPy was created with the entire data science pipeline in mind. If we wanted to have VerticaPy functionalities using Python, we would have to combine 3 main Python modules: scikit-learn for machine learning, pandas for data preparation and exploration, stats model for time series analysis. We coded our own functionalities from scratch to ensure scalability. We will never have as many algorithms as scikit-learn, but we are always trying to implement anything that could possibly scale and be enough performant on big data use cases. Besides, VerticaPy offers amazing data exploration capabilities. With more than 80 different charts, it is possible to easily understand your data. No need to have an extra library to do it. One API to help you discover all the insight you need. The goal behind VerticaPy is to create the best data platform for machine learning. By combining 4 main topics: automated machine learning for citizen data scientists, scalable machine learning and data preparation at scale for data scientists, and data exploration and visualization for business analysts. In VerticaPy, it is also possible to query external databases. For this topic and the demo, I will hand it over to Umar. Umar, the stage is yours.
Thank you, Badr. Continuing the topic of reducing TOC, I will talk about DB-Link, which is another amazing feature of Vertica. DB-Link is a user-defined extension coded by one of the most talented pre-sales we have. It uses an ODBC connection and pushes the SQL execution to the target database. We only retrieve the result set and use it in our Vertica query. It can push any DDL, DML, DQL, or DSL statement to the target database. Just imagine being able to query any data source. When I say any data source, I mean other databases or in-memory objects. For example, let's say that you want to join a source in Vertica with external sources, one in MySQL, another in Postgres, and finally one in memory using Pandas data frame. VerticaPy allows you to easily do the operations in a convenient Jupyter notebook. You can create different connections by using a special symbol for each. VerticaPy will use ODBC connections to connect to each of the external sources, push or pull the data depending on the use case, and materialize all the data sets. Everything will be done automatically behind the SQL Magic Cell syntax. Everything becomes so easy. And that's not all. DB-Link capability is also extended to vData frame, which is the core object of VerticaPy. Whenever it is possible, the vData frame can send the generated query to the external database to save computational resource. Vertica will use an ODBC connection to the external database, which will compute the aggregation and send them back to Vertica. after which the result will be displayed to the user. With Vertica open architecture and VerticaPy flexibility, it is now so easy to follow the entire data science lifecycle anywhere. Vertica is the most advanced analytics platform that can do it all, serving business analysts, data scientists, and providing the performance, scale, and control that every analytics team needs to meet their business expectations. Analyzing data in HDFS data lakes, applying full ANSI SQL database management to S3 object storage, delivering use cases spanning real-time fraud prevention and credit scoring, predicting customer churn, and improving every customer experience. That's Vertica. Now that we know all the power of the Vertica database, let's do a quick demo. In this demo, we try to showcase some important DB link and VerticaPy functions that reduce the TOC. Let us start by importing all the necessary libraries. As mentioned, DB-Link can access any external database. So let us first try to set up the connection with airline database placed in Postgres. We can select a special symbol that we can use to access tables from this connection. In this case, it is the $sign. Next, we can set up a connection with MySQL to get the airport data. Next, let's try to load a data in our Vertica database. Now, let us see how we can use SQL magic with DB-Link to conveniently query databases from different sources. SQL magic allows us to use pure SQL queries inside Jupyter notebooks, so there is no need for a separate tool, thus reducing the TOC. Here we can query the Postgres database along with the Vertica database to perform a join and select query. Let us try to find how the flight delays are distributed among airlines. We can use the convenient charts to represent this data so intuitively. The graph clearly indicates that airlines influence delays. DB-Link allows us to perform queries involving multiple external databases. There is no limit on the number of databases that can be queried. Let us try to find a combination of airport and airline that performs most poorly while taxiing. In this query, we fetch airport table from MySQL, airline table from Postgres, and flights table from Vertica. Just notice the ease of syntax of DB-Link for querying multiple databases. This allows us to reduce the TOC as the external table does not necessarily need to be ingested before we perform the operations on it. We can even push queries to external databases by just placing them inside the special characters. For example, here. Next, I will just quickly showcase the data science friendly functionalities of VerticaPy, starting with data exploration and preparation. Notice how there is no proper date information for any entry. We can easily create this feature using the eval function of VerticaPy. Here we make features that have the date information for scheduled departure, wheels off, and wheels on. We can even write long, complicated SQL queries using this eval function. Here we try to make some more features which capture the lag information of a particular plane. VerticaPy even has advanced functions like rolling averages to calculate averages for moving windows. VerticaPy also has advanced analytic functions that make calculating advanced analytics so easy and intuitive. Next, we can use VerticaPy graphs to show the influence of last flight delay on current flight delay time. The results are obvious and clear. Based on our insights, let us try to store some relevant columns that we can use to build a delay prediction model using random forest classifier. VerticaPy has in-database machine learning, which makes training and prediction super fast and scalable. VerticaPy trains and automatically outputs the relevant metrics that you may need to judge your model. To summarize, in this model, we demonstrated the convenient capabilities of VerticaPy, which make it such an attractive data science tool, starting from DB-Link all the way to machine learning. It is a unified platform where the business can reduce the TOC by not paying for and maintaining multiple tools for different aspects of the data science pipeline. During the presentation, we have tackled three main points. VerticaPy helps any company to reduce TCO by combining many functionalities into one. Thanks to Vertica architecture, it is performant. It provides built-in machine learning without any additional cost. And with DB-Link integration, no need to buy an extra technology to be able to query anywhere. Vertica is a complete technology with an open architecture. No need to buy extra software or hardware or to hire more consultant. Everything is more directly included within the product. You can then easily follow the data science lifecycle without exiting the product. I hope that you will find these capabilities extremely useful in your businesses. We are constantly trying to make data science convenient and efficient by bringing you amazing features. To support us and to get updated on all our latest features, you can start our project on GitHub. Thank you very much for being part of this webinar. We will now be taking questions. Let's switch to the Q&A.